Do you know how to represent an irrational number of this type on number line? So, today we will learn to represent the square root of a positive decimal number on number line. To do this, now I am going to tell you, first of all, we will make a number line, or you can say that O is the origin of number line. Now make some partition here. Say this is 1 unit, 2 unit, 3 unit, 4 unit. Here is also 1, 2, 3, 4. Now take a point A at the left, take a point A at the right of origin at a distance of 1 unit. Take a point A on the right of origin at a distance of 0.5 unit. Take a point B on the left of the origin at a distance of 4.5 unit. So 1, 2, 3, 4, 5. So I have to take 4.5. So this is 4.5. Name this point as B. So I have take a point B on the left of origin at a distance of 4.5 unit. Right? Now we'll bisect the line AC. What we have to do? We have to perpendicularly bisect the line AB. So to do this, we will take a B as center and draw an arc here and here. Same as with the same distance in your compass, take A as center and cut this line. Now if we join these points, we will get the perpendicular bisector of AB. Listen carefully, we have to bisect AB, not OB. We have to bisect AB. So the perpendicular bisector cut the number line PB or PA as radius. Taking P as center and PB or PA as radius, make a semicircle here, right? So taking P as center and PB as radius, we will draw a semicircle here. Now we will draw a perpendicular line from O. The perpendicular line intersects the semicircle at a point, let's say C. Right? We will draw a perpendicular line at point O and let the perpendicular line intersect the semicircle at point C. So the OC is nothing but square root 4.5. This OC is square root 4.5. Now, and OC as radius, right? What I am saying, taking O as center and OC as radius, draw an arc which cuts the number line. Draw an arc which cuts the number line, let's say at point D. Right? Taking O as center and OC as radius, we will draw an arc which cuts the number line at point D. This OD is square root 4.5 unit. Now, since O, okay, please take a screenshot of the solution. Then we will discuss one more example for better understanding. Please. Okay. Now let's take another example. A number, suppose 3.2 on number line, right? So To do this, we'll repeat the same method as we done in previous questions. First of all, we'll draw a number line. Right? We'll draw a number line. The origin of number line. The point O is the origin of number line. Now, take a point A on the right of O at a distance of 1 unit. What I'm saying? Take a point A on the right of origin at a distance of 1 unit. So this is your point A. Now, on the left of O, take a point B at a distance of 3.2 on number line. On the left of the origin, take a point B at a distance of 3.2 on number line. So 1, 2, 3. Let's extend this number line. 1, 2, 3, 4. Now 3.2 may be here, right? So this is your point B. Now we'll draw a perpendicular bisector of BA, right? We'll draw a perpendicular bisector of BA. So let's do this. We'll draw a perpendicular bisector of BA. Now let the perpendicular bisector cut the number line at a point P. Right? Now taking P as the center, and PA or PB. PA and PB both are equal because we have draw a perpendicular bisector of let's say this perpendicular line bisect something. I hope this perpendicular line bisects something here, right? Now let's say this is the point P. Now taking P as center, and PA or PB as radius, will draw a semicircle. Taking P as center and PB as radius, or you can say that PA as radius because both are same, will draw a semicircle here, right? Now from the point O, draw a perpendicular line which will intersect. From a point O, draw a perpendicular line which will intersect the semicircle, let's say at a point C. Now this OC is nothing but square root 3.2. This OC is, let's take O as the center, and OC as the radius, and draw an arc which will intersect the number line, let's say at a point D. Now this OD is what? Square root 3.2 unit. Right? Now, since O is the origin of this number line, so you can say that point D represents square root 3.2. So, hence you can represent square root 3.2 on number line. Please take a screenshot. Okay, now I hope you can represent any irrational number of this type on number line. So, please note down some homework to do in your homework copy. Please do practice to represent the following number on number line. Let's say you can represent square root 9.3, square root 2.5. First of all, you will represent square root 1.5, 2.3, and then square root 9.3 on number line. I hope you can do this in a very easy way, right? Please note down this question. If we write the square root of 3, the square root of 3, then this sign, that is this one, this sign is said to be radical sign. Radical sign. And the value in this square root, the value in the square root, that is 3, is called radical. Right? This 3 is called what? Radical. Sorry, radicand. This 3 is called radicand. And the term whole, that is the whole term, that is square root 3, is called radical. Right? I hope you understand. Let's take another example. If I am writing here the square root of x, then this is what? This is the radical sign, right? This is the radical sign, and this is known as radicand, right? And the whole term, and this whole term, this is your radical sign, this is radicand, and this whole term is called radical. Right? This whole term is called what? Radical. And the degree of this radical, the degree of this radical is what? Since it is square root, so the degree of this radical is 2. Let's see another example. Suppose we are given cube root 5, right? Then, and the cube root 5 is what? Radical. And 3 is degree of radical. I hope the radical sign, and the whole term is called radical, and the degree of this radical is what? 3. Same as 10 of this radical is what? 5. Can we represent a radical in the form of exponent? Let's see one example. 2 square root 2. We can write square root 2 as 2 raised to 1 by 2. Right? We can write square root 2 as 2 raised to 1 by 2. Same as cube root 5 can be written as 5 raised to 1 by 3. Similarly, fourth root of 6 can be written as 6 raised to 1 upon 4. Okay? In general, nth root of x can be written as x raised to 1 upon n. X raised to 1 upon n. Right? What we have to do, we'll raise the power in the denominator of 1. What is the degree of this radical? N. So we can write it as 1 upon n. The degree of this radical is 4. So we can write it as 1 upon 4. Right? Okay. Now, you have already studied about the law of exponent. Do you remember? Let's recall the knowledge about what? The exponent. So, the law of exponents. Okay, the law of exponent. The first law states that if we write a raised to m multiply a raised to n. What is here? See, a raised to m multiplied by a raised to n. Now, we can see here the base is same and the exponent are different. So, if we have two numbers which are getting multiplied and if the base are same, then in the result the base is kept as it is. That is, the base will remain a and the exponent are multiplied. The exponent are added. That is, a raised to m multiplied by a raised to n can be written as a raised to m plus n. Right? Similarly, the second law states that a raised to m divided by a raised to n can be written as a raised to m minus n, because the base are same, right? So this is a whole to be raised m minus n. Here m is the exponent of numerator and n is the exponent of denominator. Similarly, the third law states that if we have a raised m whole to the raised n, then we can write it as a raised to m multiply n. A raised to m whole to the raised n can be written as a raised to m multiplied by n. Okay? And the last one is, if we have a b raised m. Here the bases are different. A multiply b raised to m. So we can write it as a raised to m multiply b raised to m. Right? Please take a screenshot. Now, let's see some example related to exponent. Suppose if we are given 64 raised 1 upon 3, we have to find the value of 64 raised 1 upon 3. As we know that 64 can be written as 4 multiplied 4 multiplied 4. Is not it? 64 can be written as this, or we can write it as 4 cube. Right? 64 can be written as 4 cube. Now, 64 raised 1 by 3 can be written as 64 as 4 cube and whole to the raised what? 1 upon 3. Now, as we learned that if we have a raised m whole to the power n, then the result will become a raised to m multiply n. Right? So the same thing will be done here. That is 4 raised 3 multiplied 1 upon 3. Now, if we solve this, then 3 and 3 will be cancelled out and we have left 4 raised 1. Right? Or you can say that this is what? 4. So, 64 raised 1 upon 3 is nothing but 4. Right? So, hence you can do the problems related to exponent. Let's see some other examples. Take a screenshot. Let's see some other example. (32 raised 1 upon 5). Now we will do the same thing as we done earlier. 32 can be written as 2 into 2 into 2 into 2 into 2, right? Or you can say that this is what? 2 raised 5. So 32 can be written as 2 raised to 5, right? Now 32 raised to 1 by 5 can be written as 32 can be written as 2 raised to 5 and whole to the raise 1 upon 5. Or this can be, this will become 2 raised to 5 multiply 1 by 5. As we know that according to exponent rule, a raised to m whole to the raise n is equal to a raised m multiply n, right? So here 5 and 5 get cancelled and we have left what? 2. So the 32 raised to 1 upon 5 is equal to what? 2. Please take a screenshot.